Welcome back to another video. In this video, we're going to talk more about sets. In particular, we're going to talk about natural numbers, finite sets, infinite sets, cardinality, and equal and equivalent sets. Okay, so before we get started, I just want to say I hope you're having a great day. Remember, you can do anything you put your mind to. You just only got to believe and work hard at it, and trust me, you can accomplish it. So don't let math make you feel any type of negative way. You got to think positive about it and know that you can conquer this math. Okay, so let's get started. We want to first talk about natural numbers. Now, a natural number is what we call counting numbers. So when you first learn to count, you first learn 1, 2, 3, 4. Like, you don't learn 0 when you first learn to count. You start with 1. So natural numbers, which we denote as a capital N. So usually when we handwrite it, we write 2 lines on the end, but usually when you see it printed, it's a bold N. So that represents the set of natural numbers, and that's the set that contains 1, 2, 3, 4, 5. Usually when you first learn to count, you learn how to count to 10, but it actually keeps going. So I'm going to put dots in here, and that represents the fact that it keeps going, and it keeps going and going and going and going. So it actually keeps going. And that means it goes to infinity. Infinity isn't a number, it's a concept. That means it continues on and on forever. So this is the set of natural numbers. It starts with 1 and then it keeps going. And it's the numbers that you count. Okay, for example 1, we want to express each of these sets using the roster method. So starting with part A, it's 3 different parts. We want to say set A is the set of natural numbers less than 5. So remember, the natural numbers are your count numbers, 1, 2, 3, 4, 5, and it keeps going. But if I just want the set of numbers less than 5, and I'm going to squeeze it in here, then A will be the set of 1, 2, 3, and 4. And because I only wanted less than 5, then I would stop at 4. So this would be how I would describe set A using the roster method. This right here. Hopefully y'all can see it. I know I squeezed it in there, but you should be able to see it, all right? Set B is the set of natural numbers greater than or equal to 25. So for set B, that would be, so since it also wants the set of numbers equal to 25, I would start with 25, and then I want all of the numbers greater than 25, so I would continue to go 26, 27, 28, and it would keep going. And so I would just put dots to let you know that it keeps going. It doesn't stop, because that's all of the numbers that are greater than or equal to 25. Now for part C, it wants the set E to be the set of all X. So remember, this is set builder notation. So this says the set of all X such that X is an element of the natural numbers. That means X is a natural number and X is even. So basically we want all of the natural numbers that are even. So E would be 2, 4, 6, 8, and you will keep going in that pattern. You're basically skip counting, but every other number would be in that set. So the dots let you know you keep going in that pattern. And so this is how you would describe set E. All right, so this is example 1, how you can go and express some numbers or some sets that contain natural numbers using the roster method. Let's look at some more examples. Okay, for example 2, we want to do the same thing we did in example 1. We want to express each of these following sets using the roster method. So the first one says that X is the set of all X that are natural numbers, and X is less than or equal to 100. So I want basically all of the natural numbers that are less than or equal to 100. So it didn't give this set a name, but we'll just write it out without giving it a name. But all the numbers less than 100, so natural numbers start with 1. So basically you'll start with 1, you'll go 2, 3, 4, and you'll keep going all the way up till you get to 100, because it also wants it to equal 100. So your set will stop at 100. And so that's how you would express this set using the roster method. All right, let's look at the second one. So this one says you want all of the X such that X is a natural number and X is greater than or equal to 70 but less than 100. Okay, so that means you're going to start this time with 70. You want it to equal 70, so you'll start with 70 and you'll go 71, 72, 73. You'll keep going all the way up to 100. But since there is no equal to sign for 100, you don't want it to equal 100. You'll stop one number shy of 100. which is 99. So your set will look like this, 70 all the way up to 99. So that's how you would express both of these sets using the roster method, okay? Any questions? No questions, no questions? All right, if you have a question, put it in the chat or send me an email, okay? Now I want you to take a moment and try to work this problem on your own. So I want you to pause the video and try to work this and see what you get. So pause the video for a moment. Alrighty, so first of all, you have to understand how to read this expression or how to read this statement in order to work it out. So hopefully you read this as the set of all x such that x is a natural number and x is less than or equal to 200. So since we know that x is a natural number, that means you're going to start with 1, you're going to keep going all the way till you get to 200. And since it says equal 200, you will include 200 in that set. So did you get this? If you got this, good job. If not, try to go back and understand where you went wrong and understand your errors. Understanding errors is a big part of learning how to do anything, but especially learning how to do mathematics. So hopefully you got this. And so let's move on to the next topic. Now we're going to talk about what's called a cardinal number. So the cardinal number is the number of distinct elements in a set, okay? So when I say distinct, that means if you have an element in the set that's repeated more than once, you only count that element once, okay? So if you had like 3 in the set 3 times, you would only count 3 once, all right? So it's the number of distinct elements in the set. You can also hear it referred to as the cardinality of a set. So you're counting how many numbers are in the set. So we're going to look at some examples where we actually count the cardinal number of each set. So for example, 3, we want to find the cardinal number of these 4 sets. So starting with set A, it has 7, 9, 11, and 13 in it. That means there are 1, 2, 3, 4 numbers in this set. So the cardinality of A will be 4. Now we write that like this. We call it N of A. That's like saying the number in A is equal to 4. So the cardinality of A is 4. Alrighty. So now when we look at B, B only has 0 in it. So B has 1 element in it. So we will say the cardinality of B is 1, or we write N of B equal 1. Now we look at C. C has a little bit more elements in it. It has 13, 14, 15. It keeps going 16, 17, 18, 19, 20, 21, 22, 23. And so you want to count how many elements are in C. So you would say 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Now you see I counted 11 items. You don't want to just subtract 23 from 13 because that will give you 10. But if you actually count them out, there's 11 items in C. So the cardinality of C is 11. And we write N of C equal to 11. Alrighty. Now remember what this is. Y'all remember what this is called? See if you can remember. What's the name of this? This is the empty set. So if you say empty set, you are correct. Empty set is a set with no elements in it. So since there are no elements in the empty set, then the cardinality of the empty set is 0 because it has no elements in it. And we write N of the empty set is equal to 0. Okay. So this is the cardinality of a set. You're just basically counting how many items are in a set. All right, the next topic we want to talk about is equivalent sets. So this is going to be a little bit confusing. It's not really confusing. You just got to pay attention to it. The terminology is really, really important. Equivalent sets versus equal sets. So we're going to talk about equivalent sets first. So equivalent sets, 2 sets A and B are said to be equivalent if they have the same number of elements in each set, okay? So as long as they have the same number of elements, they're considered to be equivalent. Now remember, we use N of A and N of B to represent the number of items in each set. So set A is equivalent to set B if N of A is equal to N of B. Alrighty. Now that means that you can create a one-to-one correspondence between each set. Okay. So for example, let's say A was equal to the set of vowels, which are A, E, I, O, and U, and say B was equal to the set 1, 3, 5, 7, and 11. That's your odd natural numbers up to 11. Okay. The number in A is 1, 2, 3, 4, 5. So your N of A is equal to 5. The number in B is 1, 3, 5, 7, and 11. So your n of B is also equal to 5. So since these two numbers are the same, then you would say set A is equivalent to set B. Now, what does it mean to be able to create a one-to-one correspondence in between them? That means you can align each one. You can align an element with an element, you can align an element from this set with an element from this set, and there are none left over. So like I could assign A to 1, E to 3, I to 5, O to 7, and U to 11, and there are none left over. So basically you can pair them all and none are left over. So that's what it means to create a one-to-one correspondence between them. So sets are equivalent if they have the same number of elements in each set. Okay, I have some more terms for you. We're almost done, but the first term I want to talk about now is finite sets. A finite set is a set that has either 0 as its cardinality or an integer as its cardinality. That basically means you can actually count how many elements are in the set. Now, an infinite set is a set where you cannot count the number of elements in the set. So for example, if I had set A that was 1, 3, 5, 7, and 11, then you could look at that and you could say, okay, there are 1, 2, 3, 4, 5 numbers in that set. So n of A is equal to 5. So its cardinality is actually a natural number. Alrighty. So that one will be considered finite. However, if I said B was the set of all odd natural numbers, then I would keep going. And then in this case, since you continue to go on, you cannot count how many elements are in this set. There are an infinite number of elements. It's not infinity, it's not a number, but there are infinitely many numbers in this set. So B will be considered an infinite set. So A is a finite set and B is an infinite set. All right, now the last term I have for you in this video is equal sets. Okay, so we talked about equivalent sets earlier. That's when two sets have the same number of elements. Now, equal sets is when two sets have the same exact elements, okay? So every element that's in A is also an element in B, and every element in B is also an element in A, okay? So I have two examples, or one example with two different parts. We want to determine whether each statement is true or false. So this says that the set with 4, 8, and 9 in it is equal to the set with 8, 9, and 4 in it. Okay, so we want to look and see, do they have the same element? So this set has a 4, this one has a 4. This set has an 8, this one has an 8. This one has a 9, this one has a 9. So those two sets have all of the same elements. So in this case, that is true. Those are equal sets. And notice, if they're equal, they're also equivalent. But if they're equivalent, that doesn't mean that they're equal. I know it might be a little confusing, but just know, equivalent is only counting the number of elements in the set, and equal is actually looking at what's in the set. So this one would be true, okay? Now let's look at this one. This says that the set with 1, 3, and 5 is equal to the set with 0, 1, 3, and 5. Now this set has a 1, this one has a 3, this one has a 3, this one has a 5, this one has a 5. This one has a 0, but this one does not have a 0. So since these sets do not have all of the same elements, these are not equal, and so this statement would be false. Alrighty, and so that's how you determine whether a set is equal or not. You will look at the elements and compare them, and if they both have all of the same elements, then they are equal sets. So hopefully everything in this video made sense. If not, please don't hesitate to ask questions. You can put them in the chat or you can email me. I will respond. And if you haven't already, make sure you go on and hit that subscribe button for me. And thank you for tuning in, and I will see you in the next video.